What's up, guys? We're looking at Unit 9 on the Python course for CodeHS, and it's got a few different things about lists, which we've already learned, but there's more you can do with them. And it's got dictionaries, which is a new thing, and it's got equivalence versus identity. Sometimes you're testing if two variables have the same value, and other times you're testing if two variables are exactly the same guy. And often, if you do one but you think you're doing the other, that's where errors come in. So let's look at some examples from the 2D lists. When I made an example of tic-tac-toe last quarter, I think I showed one where it was just 9 straight in a list, and then I showed another where it was 3 of 3. And obviously they're both fine, they both work, but we have choices. We have different ways of looking at things, and that's good. So this is going to use some row and column style list of lists, kind of like I did on my 2048 or my Connect 4, which are bigger than tic-tac-toe, and you don't want to have, like, you know, a list of 56 guys or whatever. So checkerboard 1, 2, 3, we're going to look at these because they all add up to one big thing. It's going to say our final goal is to make this checkerboard with a strip in the middle of blanks. So it's got checkers, blanks, checkers. And that's not what we're doing on part 1. On part 1, we're doing 3 rows of one thing, 2 of another, and then 3, but back to the first. So it's going to tell us to create a grid, okay, and then change some of them, and then print it. Sure. We don't have to do this. The print function is already made for us. What it says is take the number, convert it to a string, and then put blanks between them so it looks pretty instead of being all squished together. Or if you just print a list, it's going to have commas and brackets and sometimes quotes, and it looks pretty bad. You wouldn't do that unless you were just like quickly testing something. So what we need is to make a grid. I'll just call it grid. And we could type everything here. We could just do like 64 different spots, but that would take forever. And you could do for loop. You could do, okay, I'm going to say like for I in range 8, grid dot append, and then I'm going to type a row of 8. I could have made a nested for loop and only typed it once, but this is fine. We get the result of 8 by 8 zeros, and I can print that to show it by sending the grid I just made to this function up here, and that's going to give us an answer. That's not the whole thing. I need to add something between those two, but that's just to show how it works. So between those two, what it wants us to do is to say the first 3 rows are all 1, and 5, 6, 7 are all 1 as well. So I did this earlier with enumerate when I was testing it out because I thought that sounded like a good spot for it. And it worked. It gave the right output, but it didn't pass the grader. The grader wants a nested for loop because it says a nested for loop. So I'm going to do it without the enumerate, even though I love it. Let's say for row in range 8 and for call in range 8. Remember, you could use I and J or X and Y, or maybe Y and X to switch it to be right. But row and call sound good to me because they're describing what we're doing. And often with stuff like this, you don't even need a range. You just do the items directly. But for this one, I think it makes sense, especially when you can't do enumerate, like I said earlier. So what do we need to say? Well, if the row is 0, 1, 2, or 5, 6, 7, then we make the whole thing 1s. And if the row is not, well, it was already a 0 because we made them all zeros here. So I'm going to do a little if. Okay, if row is, we can say like 0 less than or equal to 2, or 5 less than or equal to 7, then the whole thing equals grid row call equals 1. I think that's reasonable, because we only have to do one at a time. Since we're doing the double loop, it's going to every single guy. If you loop on the grid itself, then it does one row all at once. But then if you have a loop inside of that, it does each little guy on its own. So we only need to change one at a time. Once we're this deep, we're only looking at one. And there we go. I think that's what we need. Let's try it. But I didn't type that. Oh. I didn't type. What was I doing here? I didn't type anything. Maybe I got distracted in the middle of that line. Okay, that's what we need, right? You could put parentheses around here to make it prettier, to show that, hey, this is one thing and this is one thing, but it works without it. So we're saying it's got a nested for loop. It's doing all this stuff. It's saying we're going through the whole board, and if the row is a certain first 3 or last 3, then we change each guy to 1. Now that is getting us here. This is not our final answer, because our final one is going to have the checkerboard on those sections. But it's a good start, right? So let's go ahead and copy this, because we'll probably reuse very similar code on the next guy and the next guy. And this is not the only way to do this. Like I said, you could do a double loop here and just append one at a time, or you could do it a bunch of different ways. And you could do probably this a bunch of different ways too. This is what came to mind first. It's not the prettiest. It's probably not the fastest, but it's all right. So version 2 is going to say, okay, forget about the different rows and the strip in the middle. We're going to save that. We're just going to practice alternating diagonals like checkers. So the way to test diagonals, or one way to test diagonals, is something I mentioned on my tic-tac-toe. And I didn't end up doing it because I thought it was kind of ugly, but it does work. Is if you take row and column, add it up, if that's even, then it's, you know, black, and if it's odd, then it's white in terms of your checkerboard. So we can add them up and use this guy, which is modulus of or modulo, in dividing something and telling you if there's a remainder. And 90% of the time you use that, it's divided by 2 to tell you if something's even or odd. So let's do that. Oh, I already had it earlier. Let's type it again. Let's copy the guy from the last one and say, okay, we still need to make a blank board to have something to mess with. And we're still probably going to go through each row and column. And then we're going to say if row plus call, I think mod 2 is how you say that if you're a math guy, is 0, then we turn our guy into 1, and then we run it, and that does checkerboarding, and that does pass the test. So it turns out that this is almost the same as the last one, even though it's a totally different output, right? It's checkerboarding instead of strips, and you know, one row is all one thing, and there's some stuff in the middle. Even though it's a totally different looking output, it's almost the same code, because you're still making the grid, going through the grid, and the only part we need to change is what criteria allows us to do something new this time. So guess what? The next part is going to combine them. It's going to say, we want checkerboards for this, and then a strip of zeros, and then checkerboards for this. So it's going to have no new code, really. It's just the same stuff we've done on the last one, plus this thing. That's it. I'm going to close that. Checkerboard volume 3, or version 3, I don't know what they have in mind with that V here, is doing part of what we did on the first, part of what we did on the last, put them together. So, hey, you see it where I typed it earlier, and we don't have to do it again. But what I did was copy pasted the first guy and then said, now we're putting it through multiple tests. We're saying if it's on the right diagonal and it's not in that middle strip, it's all blanks, then it becomes a 1. And we never have to say it becomes a 0, because they're all already zeros from the initialization over here. Now, if you do this, your code does not have to be exactly the same. There are different ways to make it. There are different ways to test it. That's fine. There may even be some that are like a little bit more efficient or something, or a little bit easier to read, I'm sure. But this does the job, and it seems to fit with what they want, because we're getting the green check marks. So that is a little bit of a different type of thinking than when we're doing strings and integers. It's more in the sense of like grammar and logic, where this is more about thinking visually, like what does this grid look like? And then the next step is what are the attributes of each guy, and like, oh, if we add up the row and column, it would have a even whatever. But in terms of thinking of it visually, it might help to zoom out a little bit and have less focus on what's the variable name or something, and more focus on like, oh, what are we doing in general? What's our thought process? How are we, like, you know, like earlier I was vacuuming the room and I was thinking of like, do I want to go rows this way? Do I want to go this way? Do I want to sometimes do diagonal? You know, all of this stuff of like planning of like, oh, there's a desk over there. Should I move it and go in those spots, or should I just kind of wiggle the vacuum to get most of what's under that desk? That kind of thing might help. And when they do a checkerboard and actually print it like a checkerboard, that highlights what we're talking about. There is a tic-tac-toe thing on here, but it's not asking you to make tic-tac-toe. They already made most of it, and they're just asking you to add a tiny bit at the end. If you saw me make multiple tic-tac-toe games, so you've seen a lot of different ways to do it. And even though theirs is not the same, it really is the same with different words, right? So list comprehensions, which come next, are really nice. I don't want to make this video super long, so I might not do all the examples, but list comprehensions are when you say, I want to go through a list and change stuff, or use that to make a new list. It's not always a giant, deep, nested for loop the way you might think. There is a better way, and it's called list comprehensions. So when we were doing some nested for loops a couple weeks ago, I often told you that the natural way to think about it is that your brain starts in the middle with like the key action, and then you expand of how does it loop, and then how does it loop around that. This is more natural in that way. Your brain says, hey, what are we doing? And then how does it get wrapped around with various criteria? So like, we're squaring it. X times X is just a fast way to say square, but you could also say the POW, like X and then 2, you send it those arguments. Or you could do X star star 2. There are a lot of different ways to square, but this is fast. X times x for x in range 1 to 6. So instead of making a for loop with multiple lines and things going on, sometimes list comprehensions are way faster and more readable. So often you could make something faster by squishing together weird symbols and mathy stuff, but it would be slower when somebody actually had to look at it. And this is not the case IMO with these, because this is very nice and human and logical. So if you were to print that, it would make a list of 1 squared, 2 squared, 3 squared, etc. And that's pretty nice. I'll end it here because the video is 15 minutes and I don't want to make something longer than that. But you'll see that every once in a while, you could write a 5-line super indented, massively deep for loop, or you could write like a 1-line thing to do the same job when you're doing a list. So they're pretty nice.